Alright, so today is Unit 4, Day 2. Solving inequalities by adding or subtracting. So, the funny thing about inequalities is we treat these symbols, the less than, or the greater than, less than, greater than, equal to, less than, equal to, we treat those all very similarly. We treat them just like we treat them almost like an equal sign, okay? In the sense that in order to solve these, we do the opposite of what we were doing. We solve them just like a normal equation, okay? We're just using different symbology in the middle. So we're going to go ahead and subtract 3 from both sides of number 1, and that's going to leave us with m greater than 2. Just like normal, okay? Now, it says that not only do we have to solve each inequality, but we have to graph these solutions. Now, on number 1, we have 2, okay? And then we're going to put, if you all remember from yesterday, since there's no line underneath it, we're going to put an open dot above the 2, and m has to be bigger than that, so everything to the right. Alright? Now, number 2, we're going to add 5 to both sides of this. And that's going to be g greater than or equal to 0. Alright, so we put a 0 smack dab in the middle. And g has to be bigger, so we're going to go to the right. Now, if you notice, we have this little line underneath the greater than symbol. Okay? That little line means that we're going to shade this dot in. It's going to be an enclosed circle. Okay? Now, some of y'all are probably wondering, well, at some point, he's going to mention something about checking our answers. And yes, I will. Okay? So, here's how we check answers on these. We're going to go negative 5 plus 0. Okay, that is what we came out with, right? That needs to be greater than or equal to negative 5. Negative 5 is, in fact, greater than or equal to negative 5. Okay, but that doesn't fully check this answer. We need to go ahead and we need to try something in our region. Okay, 1 is in the region. So we go negative 5 plus 1. And figure out if that is greater than negative 5. Negative 5 plus 1 is negative 4. Negative 4 greater than or equal to negative 5. That is a true statement. Therefore, this answer is checked. And it's going to work. Alright? So, moving along here. We've got number 3. Whoa, everything moved. Alright. Okay then. So, on number 3, we're going to add 7 to both sides of this. That's going to leave me with x less than or equal to 7. So we put a 7 right in the middle of our graph. We're going to shade in this circle. Okay, and that's x is smaller than 7, so it's going to be everything to the left of 7. Okay, that's an arrow, by the way. Okay, and of course we could check it the same way. You could pick anything that's smaller than 7. You could even pick 3 and plug it in, and 3 minus 7 is negative 4. Negative 4 is, in fact, less than 0. Okay, 7 minus 7 is 0. That's equal to 0, which falls into the right bracket. Okay, so next we're going to do number 4. We're going to subtract 11 from both sides of this. That's going to be negative 19. Greater than or equal to w. So negative 19, that's going to be a closed circle. And w needs to be, if you notice our arrow, okay, We're chomping on the negative 19. That means the negative 19 needs to be bigger, which coincidentally means that W has to be smaller. So, W is everything smaller than negative 19. Okay? So all of this over here is W. We could plug in anything we want over here in place of W, and it would work. Okay? Alright. Moving along here. Moving along. Let's see if I can get those to go away. There we go. Okay. Alright, number 5. We can add 1 to both sides of this. And it's going to be 5 less than P. So we put a 5 in the middle with an open dot, and P needs to be bigger. So it's going to be everything to the right. Alright. Okay, number 6. Not much different. Not that much different. All we got to do is collect our like terms here. And that's going to leave us with Q minus 3.5 less than 7.5. Okay, and then we add 3.5 to both sides. Okay, and Q winds up being less than 11. Okay, so we put an 11 in the middle, open dot, and Q is less than that, so that's Q going that way. Alright, number 7. Alright, let's see, we're going to start by subtracting 2.4 from both sides of this. Minus 2.4 and minus 2.4. That's going to leave me with negative 3.6. Greater than or equal to y. And then, let's see. So we put a negative 3.6 in the middle. And that's going to be a closed dot. And y needs to be smaller, so that's going to be everything to the left of y. Alright? Now, let's see. Number 8. We're going to go ahead and we're going to add 3 to both sides of this. And that's going to be 5.5 less than t. So we put 5.5 in the middle with an open dot. Okay? And t needs to be bigger than that. So, everything to the right. Okay? So, and then one other thing. Don't leave that at 5.5. Use the fractions. They're very useful. Okay? Other awesome answers include 11/2 less than t. Alright? Let's see. Next up, we've got 6.2 less than r plus 2.2. Now, since this is asking me with decimals, I can respond with decimals. Okay? Minus 2.2 minus 2.2, that's going to be 4.0 less than r. So it's going to be 4.0 open dot, and that's going to be r greater. So r is everything to the right of that. Okay? Number 10, we're going to add 1/3 to both sides of this. And that's going to be z less than or equal to 5/3. So we put 5/3 right in the middle. It's a closed dot, and z needs to be everything less than that. So, to the left. And there it is. Okay? Not too bad. Alright, y'all. Final stretch here. So, number 11 says, if 45 plus 47 equals t, does t equal 45 plus 47? This should be a little bit of a refresher, okay? This is what's called the commutative property, if you remember correctly, okay? We swapped the places of we swapped places, right? The stuff over here on the left went to the right side of the equal sign, and yes, that is a true statement. Now, if 45 plus 47 is less than r, is r less than 45 plus 47? So that's basically saying if 92 is less than r, is r going to be less than 92? Okay, that's a no. Now, the difference between them is B is an inequality. B is an inequality. And order matters on an inequality. Okay? And that's it in a nutshell, okay? The order matters on those. We could go a lot further in depth on that, but basically you can't say 92 is less than r and r is less than 92. That just makes absolutely no sense. You're basically saying that r is two different numbers, and, well, that's a whole nother can of worms. But anyway, on number 12, we've got 3 less than a number is less than 4. Okay, so 3 less than a number, so we're using less than in two different contexts. Okay, on this one. Now, if you notice, one of them is preceded by a number. The other is preceded by the word is. Okay, now is refers to an equality, inequality, some form or a fashion of that. Okay, so this says that 3 is less than. If we remember correctly, less than is a swapped word. So we're going to do n minus 3 is less than 4. So less than 4. So we add 3 to both sides, and we're left with n less than 7. So we plop a 7 in the middle, open dot, n needs to be less than that, so everything to the left. And there it is. It's that simple. Alright, so 7 more than a number, so that's 7 plus a number is at least -1. So when we say at least, something is at least a number, that means that it's got to be bigger than that number, and the smallest that it could be is -1. Okay, so we put the smallest end of this at -1. We subtract 7 from both sides of this, and that's going to leave us with n greater than or equal to -8. So we put a -8 on there. We're going to close in a dot, and that's going to be n bigger than that, so we go off to the right with it. Okay. Okay, number 14 says the sum. Okay, if we remember correctly, the sum is addition of a number and 8. So n plus 8 is more than -2. So more than -2. So we subtract 8 from both sides of this. We're going to be left with n greater than -10. So n I don't know why I'm trying to write that down there. So we're going to go and put a -10 down here with an open dot. And let's see, n is bigger, so we're going to go off to the right with it, like that. Okay? Number 15 says that the sum, addition, of a number and 6 is less than or equal to -4. So they spelled this one out for us. Less than or equal to. So that's going to be n plus 6 is less than or equal to -4. We subtract 6 from both sides of that, and it's going to be n less than or equal to -10. So there's that. We're going to put ourselves a closed dot here. And n is less than that, so we go to the left. And it goes like that. Alright. Now, let's see. We've got some word problems to work with. Okay? So, Sammy has a gift card. She has already used $14 of the total value, which was $30. Write, solve, and graph an inequality to show how much more she can spend. Define the variable. Alright, so we're going to define the variable M as money money she can spend. Okay? Alright, so 30 was the original value of the gift card. We can subtract 14 from that and get 16. Alright, so the amount of money that she can still spend needs to be less than or equal to $16. Okay? So she needs to stay at or below $16. Okay? Now, that was a little bit of a back way to do that. Okay? But it still works. Okay? Number 17 is talking about Miss Lawrence wants to buy an antique bracelet at an auction. She is willing to bid no more than $550. So far, the highest bid is $475. Write and solve an inequality to determine the amount Miss Lawrence can add to the bid. Alright, so she wants to stay, let's see, so 550 needs to be greater than or equal, that's the most that she's willing to spend, then 475 plus whatever bid that she wants to put in. So we're going to call it B, where B is the amount Miss L will add. Okay? Now, all we gotta do is just solve this. We subtract 475 from both sides of this. And B needs to be less than or equal to 75. So we put 75 in the middle with a closed dot. And we don't want to spend any more than 550, so we got to go to the left with it. And there it is. Alright. Now, last question. It says that the juniors would like to raise more money than the seniors. The seniors have completed their fundraising for the year. So this is done. This is on lock. Okay? That's set. Which inequality shows how much more money J, the juniors, need to overtake the seniors? So 870 needs to be less than or equal to J plus 650, right? Okay? So 650. So we're going to subtract 650 from both sides of this, and that's going to be j greater than or equal to 220. So let's see, which one of those looks like that? Well, G does. And there we have it. Now, just to double check what this says, it says that the juniors would like to raise more money than the seniors. Okay? If we go back and we look at this, it shouldn't be the equal to sign. It should be just the plain greater than. Okay? They don't want to raise as much as the seniors. They want to raise more. So, J winds up being the correct answer. Thanks for watching.